Well, hello, Precalculus students. Today's notes are on counting principles. So two main ideas that we're going to get out of today's notes. They both involve taking a certain number of items, maybe two, three, four at a time. So one is called a permutation, and here's the notation for that, NPR equals, here's the formula for it. And remember, factorial means multiply the number you're given times successive integers until you get down to 1. So for example, 5 factorial would be like 5 times 4 times 3 times 2 times 1. Here's the key. Key to a permutation is these words right here. Order matters. Now the other formula, the other idea that we're going to be talking about is a combination. And notice with a combination, the order doesn't matter. Now the formulas are very similar, the notation is very similar. So if you want a permutation of 5 items taken 3 at a time, you'd write that as 5p3, and your equation might look something like this: 5 factorial divided by 5 minus 3, or 2 factorial. With the combination of 5 items taken 3 at a time, we'd write that as 5c3, and our formula would look like this: 5 factorial over, and then it's n minus r, or 2 factorial times 3 factorial. Now, using the formula isn't the hard part. Most people are okay with this. The hard part is knowing when to use each of these. And the key is these words. If order matters, we use a permutation. If order doesn't matter, we use a combination. Okay, so let's see some examples. Let's talk about when order matters, when order doesn't matter. So, first example. It says, how many ways can we select a president, vice president, and secretary from our class? So, in this case, does order matter or does order not matter? Well, let's think about it. We're selecting 3 people from our class. Now, let's just say, I'm going to say our class has 20 people. So, number of people to pick from is 20. And we're selecting 3 of them. So we're going to say R, the number we're selecting, is 3. Now, does the order that we select them in matter? Well, if we were just picking 3 representatives from the class, let's say, it wouldn't matter who got picked first or second or third. But since we're picking specific roles for those people, the first person we pick is going to be the president, second is vice president, third is secretary. In this case, yes, order matters. Okay, since that order matters, we're going to use a permutation. So this is going to be a permutation of 20 people taken 3 at a time. Okay, from the formula on the previous page, we know it's going to be 20 factorial divided by 20 minus 3, or 17 factorial. Now, mathematically, this isn't too hard to do. We can, well, if you think about it, 20 factorial is 20 times 19 times 18 times 17 times 16 times on and on and on all the way down to 1. Over 17 factorial is 17 times 16 times 15 times on and on all the way down to 1. Now, if you think about this, the 17s, the 16s, the 15s, everything all the way down to 1 is going to simplify. So this whole thing is going to be equal to 20 times 19 times 18. Which, if we calculate that, that's going to be 6,840 different ways to select a president, vice president, and secretary from a class of 20 people. Okay, now let's look at how that problem is a little bit different if we just change it a little bit. How many ways can we select 3 class representatives? So in this case, order doesn't matter, because if you get picked first or if you get picked third, you still have the same role. You're still a class representative. So in this case, order does not matter. So we still have, let's just say the number of people in the class is 20. Let's say that we're still picking 3 people, so R is 3. But now it's a combination of 20 people taken 3 at a time. So the formula is a little bit different. It's 20 factorial, once again on top. But on bottom, 20 minus 3, or 17 factorial, which we had. And then we also have 3 factorial down there. So if we write this out again, we can think 20 times 19 times 18 times 17 times 16 times dot 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 on top, over 17 times 16 times dot, 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 times, and then that 3 factorial gives us 3 times 2 times 1. So now, just like before, 17 factorial reduces with 17 times everything all the way down to 1. And then we still have some other stuff we can simplify. We can simplify the 3 and the 18. We can simplify the 2 and that 6. And then this becomes 20 times 19 times 3. So slightly less than what we had before. So if we multiply 20 times 19 times 3, we get an answer a little bit less than what we had before. We get there's 1,140 different ways to select 3 class representatives. So the mathematics people are usually okay with. The difficult part is determining, are we going to use a combination or a permutation? So let's look at one more example of this. How many different 5-card poker hands are possible? Okay, so if I deal you a hand in poker, I'm giving you 5 cards. Let's say one of those cards is the ace of spades. Does it matter if the ace of spades is the first card I give you, or the last card I give you, or the third card I give you? It doesn't matter. It's in your hand no matter what. So in that case, order does not matter. So it's a combination. We're getting 52 cards, taking 5 at a time. There's 52 cards in a deck. We're selecting 5 of them. Okay, now a couple things. First of all, your calculator can do this for you. So if you're using a calculator and you press your math menu, in the probability submenu, you can find the combination and the permutation command. But I think you'll agree that this calculation isn't too bad regardless. So it's going to be 52 times 51 times 50 times 49 times 48 times 47 times dot, 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 over. Combination tells us we subtract these things first, so 47 times, I don't say dot, 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 I know that's going to be eliminated with what we have on top, times 5 times 4 times 3 times 2 times 1. So let's just start simplifying some of this. I know, let's see here, the 5 and the 50 will give us 10. In fact, the 2 and the 10 will give us 5. Let's see here, the 4 and the 48 will give us 12 up here, and the 3 and the 12 will give us 4 up here. So you may notice everything on the bottom simplified. That will always happen. You'll always be able to simplify everything on the bottom. You'll always get an integer answer for this. And if you don't want to simplify it, use that command on your calculator, or just type it in your calculator. 52 factorial divided by 47 factorial times 5 factorial. Either way you do it, we'll get the same answer. It's going to be somewhere around 2.5 million. Whoops, it's going to be 2,598,960. Okay, so the key on combinations and permutations is just figuring out when order matters, when it doesn't. Let's look at a different kind of problem. So next problem, how many ways can the letters in the word calculus be arranged? So we're not really selecting, it's not combinations, it's not permutations, but the math we're going to do is very similar. Here's how we do these kind of problems. If all these letters were different, we could just say, okay, there's 8 letters, so there's 8 choices to go in the first spot, 7 for the next spot, 6 for the next. It would just look like this, 8 factorial. Now that answer isn't quite right because there are some letters that repeat. Notice you have 2 C's. Notice there are 2 U's. There are, let's see here, there are 2 L's. Anything that gets repeated gets overcounted. So for example, if you start this with C's in this spot, then you switch the C's around, it doesn't really give you a new arrangement. So to take care of that overcounting, we divide by, well, since there are 2 C's, we divide by 2 factorial. There are 2 U's. We divide by 2 factorial again, and 2 L's. Now if there were like 3 L's, we'd divide by 3 factorial, but since there's just 2, we divide by 2 factorial. If you do this on your calculator, I recommend put what's in bottom in parentheses. And if you do that, you'll find that there are 5,040 unique ways to arrange the letters in the word calculus. Let's look at a different word. What about the word Mississippi? Well, there's 11 total letters, so start with 11 factorial, over There are, let's see here, 1, 2, 3, 4 i's, so we'll divide by 4 factorial. There are 4 s's, so we'll divide by another 4 factorial. And there's a couple p's, so we'll divide by 2 factorial. If we do that, and I'm going to put this in parentheses, we get there are 34,650 different ways to arrange those letters. Okay, you guys, that wraps up our notes for today. There are some practice problems that you should try out in your textbook, so give those a shot. Practice both combinations, permutations, and some problems like this. We'll see some of each of these on our next test.